This is question 8 of section 1 of Natural Sciences Admissions Assessment, past paper 2017. So in this question we have a parallelogram in the first quadrant, and we're given 2 points R and Q of the parallelogram, which are in terms of A. We're also given its area and we want to find the coordinates of P. So let's start by drawing a sketch of what the parallelogram might look like. So we can first label on R and Q. R is quite easy to know where it is because we have the y coordinate is 0, so it's going to be somewhere along here. And we also know that Q is further along in the x direction than R is because we have 2a, which is larger than 3a over 2, and it has some y component because of the a plus 1. And so we can now have a think about where P is going to be. We know it's a parallelogram, so P is going to be something like this, so our parallelogram will form something like this. So the first step of the solution is going to be to use the area, which we know to be 9, to work out what the value of A is. So first of all, let's recall what the area of a parallelogram is. So we're going to take the base and we multiply it by the vertical height up here to give the area. So let's substitute some numbers into that. We know that the base is going to be just the x coordinate of R because we're starting at the origin, so this distance here is just 3a over 2. Similarly, the y coordinate of Q will be the same as the vertical height because we're starting at y is 0 and going up to y equals a plus 1, so the height will just be a plus 1. We know the area is 9, so we can substitute these things in to get that 9 is equal to 3 over a over 2, the x coordinate of R, times a plus 1, the y coordinate of Q. So see if you can expand this out and work out what a should be. Well, first of all, we can just multiply up by the 2 and divide by the 3. So we get 6 is equal to a plus 1. And then we can expand this and pull everything over to one side to get this quadratic, which we solve to give a as minus 3 or a as 2. However, we can immediately discard the fact that a could be minus 3 because we know we're in this top quadrant, and if a is minus 3, then the x-coordinate of R is going to be somewhere over this way, which would be wrong. So a must be 2. So now we're ready to find the x and y coordinates of P. So the first step is the y coordinate of P. Now, we know that these two lines are parallel, so whatever the y-coordinate of P is, it must be the same as the y-coordinate of Q. And we know now that A is 2. So we know that the y-coordinate of P is A plus 1, which is 3. Similarly, for the x-coordinate of P, we know that this distance here must be the same as this distance here because these two lines are also parallel. And so we know that this distance here is 3a over 2. So the distance from P to Q must also be 3a over 2. And we have that Q's at 2a, so 2a minus the x-coordinate of P must give us 3a over 2, as I've written out here, where x is the x-coordinate of P. So we can rearrange this for x to give that x is equal to a over 2, which is just 1. And so the coordinates of P is x1, y3. And so we can see straight away that the answer is B.